Hey everybody, this is Mr. Misuro, and today I want to finish up our discussions about oceanography by talking to you guys about tides. And this is the one lesson that I think a lot of you are going to be referring back to because it has to do with the tides diagram and how to read the tides diagram and understanding what tides are. And that seems to be a recurring thing that a lot of my students tend to forget how to do as the year goes by. So, in this lesson, I'm going to explain to you what causes high tide and low tide and what the difference is between spring tide and neap tide and what causes them. And then we'll finish out the lesson by actually looking at the tides diagram and being able to figure out what is the spring tide and neap tide, what are the high tides and low tides. So, how do tides form? A lot of words, but basically, tides form because of the moon. The moon has gravity. And that gravity pulls on Earth's water. Earth's water is attracted to the moon, and so wherever the moon is, that's where high tide is on Earth. There's also another tidal bulge, there's also another high tide directly opposite the moon, on the opposite side of Earth. The reason for that is there's a couple of reasons. The first is because Earth is spinning, you get a centripetal force. And as a result, there's going to be, water being thrown out. However, it's being thrown out in one direction right under the moon. And so there's going to be an opposite tidal bulge. For every action, there's an equal and opposite reaction on the other side of the Earth. And also, aside from that idea, there's also this idea that water is draining from two sides to flood to one underneath the moon. And as a result, water can't all fit from two sides of the Earth onto one, so some of it's going to flood to the opposite side as well. So if we were to look at the Earth and the moon, and I were to draw in where the tidal bulges are, right? Earth's water would be attracted to the moon, and it would bulge out underneath the moon. Where there's a lot of Earth's water, that is called high tide. Where there is a little bit of Earth's water, the sides of the Earth that the moon is not, those are your low tides. And on the other side of Earth, there's another high tide. Two high tides and two low tides. The high tide is directly under and opposite the moon. Low tides are on the side. So if your moon is up here, your high tides would then be there and there. High, high, low, low. Water is draining from these sides of the Earth to flood to under and opposite the moon. But that's only part of it. High tide and low tide are only part of it. There's also spring tide and neap tide. Spring tides and neap tides happen on certain moons. When the sun, the moon, and the earth are all in alignment with each other, the sun's gravity and the moon's gravity pull with each other. And that creates a very high tide. If you have a very, very high tide, you also have a very, very low tide. That large difference between the tides, high tide, low tide, that is called a spring tide. And it happens when the sun, earth, and moon are in alignment with each other, which happens to be on the full and new moons. Vice versa, you also have times when the sun, earth, and moon are at right angles, where the moon wants there to be a high tide, the sun wants there to be a low tide. Where the sun wants there to be a high tide, the moon wants there to be a low tide. The sun and the moon's gravity are canceling each other out. This creates a very small difference between the tides. It's called a neap tide. And that happens on the quarter or half moons. Spring tides always happen on full and new moons. Neap tides always happen on quarter or half moons. So we're going to take a second and we're going to break and let me show you the tides diagram, what I want you to be able to actually work with in order to get this idea of how it's working. Here's a tides diagram, and here's how you actually read the tides diagram. First of all, we have the sun. The sun is right here. And let me make that a little bit more bold. The sun is right here, okay? Here are the moons, and here is the Earth. We are looking down on the Earth from the North Pole, so that dot is the North Pole. Obviously, there's only one moon on Earth, but I don't want to draw 4 or 5 different tides diagrams to ask you 4 or 5 questions. So the tides diagram is always going to have all 4 moons, and then it's just going to be up to me to say, okay, first quarter moon. If I say first quarter moon, then in your head, I want you to erase all of these other moons. All of these other moons don't exist. So, first quarter moon. Let's do high and lows on first quarter moon. Draw in those tidal bulges. First quarter moon is pulling Earth's water towards it, which means your highs would be on the 6s and your lows would be on the 12s. The opposite of the quarter moon scenario is full or new moons. Let's say full moon. As opposed to first quarter moon, if I say, okay, it's a full moon, where are your highs and lows? You would erase all the other moons in your head. Now you look at the full moon. Full moon is pulling Earth's water towards it. So now, as opposed to before, our high tides are on the 12s and our low tides are on the 6s. Wherever the moon is, that's going to be the high tide, directly under and opposite the moon. Low tide is on either side of the Earth, where the moon is not. Well, what about spring tide and neap tide? Well, remember, spring tide and neap tide always happen on full and new moons. They could have a spring high or a spring low, but they always happen on full and new moons. If you have trouble remembering that, think of the sun and think that the S's from the sun carry over. So, any full or new moon is going to be a spring tide. Any first or last quarter moon is going to be a neap tide. So let's do a couple problems. What tide would you experience at 6 p.m. on a last quarter moon? 6 p.m. on a last quarter moon. Okay, last quarter moon, right? All these other moons and all these other times really can go away. You don't have to pay attention to them. 6 p.m. on a last quarter moon. Erase all those other moons, all those other times. And that. Okay. First, let's figure out high and low. Last quarter moon's here. It's pulling Earth's water towards that, which means that we would have one tidal bulge on the last quarter, and the opposite tidal bulge would be on us. So we know that 6 p.m. on a last quarter moon, you would have a high tide. But is it a high spring or a high neap? Well, it's a quarter moon. Quarter moons are always neap tides. So this would be a high neap tide. Let's go over and do one more, and we'll do an opposite one. Let's say the question is, what tide would you be experiencing at 12 a.m. on a full moon? 12 a.m. on a full moon, okay? So you're at 12 a.m., full moon, all these other moons, all these other times can go away. So we erase them. And I know I ask you these questions at the same time, but it really would be helpful if you don't answer them at the same time. First, figure out high and low, then figure out spring and neap. So, full moon's here, 12 a.m., great. Moon's pulling Earth's water towards it like that, which means that we have one tidal bulge there. So there's one of our high tides. There's another one of our high tides. So now we have a high tide. 12 p.m. on a full moon, we have a high tide. But is it a high spring or a high neap? Well, we know that full moons are always spring tides. So this would be a high spring tide. If I go back a little bit and I say, okay, what about 6 a.m. on a full moon? So now we can start deleting these. 6 a.m. on a full moon. Well, the moon is still pulling Earth's water that way. Doesn't matter that it's 6 a.m. So your highs are still there. 6 a.m. would be a low tide on a full moon. But a full moon would mean that it's a low spring tide because it's a full moon. Full and new moons are always spring tides. So this is how you read and interpret a tidal diagram. Remember, spring tides, large difference between the tides, and neap tides, small difference between the tides. Spring tides are on full and new moons. Neap tides are on quarter or half moons. What causes the tides, high tide and low tide specifically, is the moon's pull on Earth's water. Your high tide will always be directly under and opposite the moon. Your low tide will always be to the side of the moon. All right. I hope this helped you understand what tides are and how to read the tidal diagram and how to do the work that I want you to do with it. And I hope you enjoyed the lesson. If you go back and listen to all the other lessons, you'll hear all the other stuff that I talk about with oceanography. But that's it for oceanography. We're going to move on to the next unit next, which is marine chemistry.